All right, welcome. Today we're going to do something a little different. We are going to take apart a machine that you absolutely use every single day, but you've probably never actually seen it. It's powerful, it's everywhere, and yeah, it's hiding in plain sight. Let's get into it.
So what are we talking about here? What's this invisible engine that basically powers our entire world? It's not your laptop, it's not your phone, nope. It's the motor that's inside of them. It's the electric motor. And we're about to crack it open, piece by piece.
And believe it or not, this is our guide. I know, it just looks like a simple flyer, a parts list from a company in India. But for us, this is our Rosetta Stone. It looks like a bunch of technical jargon right now, but it's actually the blueprint we need to finally understand how an electric motor really works.
Now, we're not just going to read this thing line by line, right? That would be super boring. Kind of like trying to understand a car by just reading the dictionary. Instead, we're going to be a little smarter about it. We're going to group these parts into systems based on what they do. We're going to use this catalog to build the motor from the ground up, right here in our minds.
All right, first things first. Let's dig into the components that are all about one thing, the spin. This is the very heart of the machine, its entire reason for being, to create motion. These are the parts that literally make the world go round.
So, for this part, we're grabbing 3 key items from our list: the commutator, slip rings, and carbon brushes. We're going to really zero in on the commutator and the brushes because they do this incredible little electrical dance together to make that spin happen. Let's start with this guy, the commutator. You see on the list where it says things like 54 seg or 72 seg? Well, seg stands for segments. Just picture a ring made of copper bars, each one separated by an insulator, and all of them are hooked up to coils of wire deep inside the motor. This thing right here is the absolute key to making it spin continuously.
So what does it actually do? Well, its one job is to be a super fast rotary switch. It just spins and spins, and as it does, it constantly flips the direction of the electric current flowing into those wire coils. Now, why is that so important? Well, because when electricity flows through a wire coil, that coil becomes a magnet, an electromagnet. And if you flip the current, you flip the magnet's north and south poles. And that, well, that's where the magic starts.
I love this analogy. It really is like a traffic cop, a really, really fast one standing in the middle of a roundabout. As the motor spins, the commutator is shouting directions at the electricity. Okay, you go this way. Now, quick, reverse, go that way. This constant, high-speed flip-floping of the magnetic fields creates this relentless push and pull against other magnets inside the motor, and that's what forces it to just keep on spinning.
Okay, but how do you get power to something that's spinning like crazy? That's a great question, and the answer is right here on our list, the carbon brushes. They're usually these little blocks of graphite, and they're on springs so they can keep a gentle but constant contact with that spinning commutator.
And this is the perfect way to think about it. If the commutator is that spinning record, the carbon brushes are the needle. They stay put, but they're always touching the record, feeding the electrical current, the music, from the outside world to the parts that are spinning. It's really a beautiful partnership.
All right, so we've got the spinning bits figured out. We know how the power gets to them. But what about the power itself? Before it even gets to the brushes, it needs to be managed, it needs to be tamed. That's our next set of parts from the catalog.
So if we look at our list again, we find these 2 terms, diodes and rectifiers. A diode? Super simple. It's a one-way street for electricity. That's it. It just makes sure the current can't flow backward. A rectifier is kind of like its slightly more clever cousin. It's an electrical translator. It takes the AC, the alternating current that comes from your wall outlet, and turns it into DC, direct current, which is what a lot of these motors need to run. So these parts are crucial. They prep the electricity before it even gets to the show. So we've got motion, we've got controlled power. But when you put those 2 together, you get something else. A ton of heat. And you've got high voltage electricity surging through this thing. And that's where our support crew comes in. These are the unsung heroes from our parts list that keep the whole show from, melting down.
First things first, you gotta keep it cool. Check this out.
In the motor spare section, we find a cooling fan and a radiator. Now the fan is often attached right to the motor's main spinning shaft. It's such a simple but brilliant system. The harder the motor works, the faster it spins, which means the faster the fan spins, pulling more cool air over the components to keep the temperature down.
Okay, besides heat, what's the other big danger? Electricity going where it's not supposed to go. That's what this whole rewinding and insulation material section of the list is about. You've got your enamel wire, which is the lifeblood carrying the current,
but it's wrapped up and protected by layers of varnish, heat-resistant fiberglass sleeves, and all tied together with cotton tape. Every single one of these things has one critical job: keep the electricity on its path and out of trouble.
Okay, we've met all the individual players, we've got our spinners, we've got our power managers, and we have the crucial support crew. Now let's put it all together. Let's step back and reimagine this machine, not as a random list of parts, but as one single elegant process.
So check this out. Here's how it all happens in this beautiful, logical sequence. Step 1, power comes into the motor. Step 2, our rectifiers and diodes get it ready, making sure it's the right kind of power flowing in the right direction. 3, the carbon brushes make contact and pass that power to the spinning commutator. 4, and here's the magic, the commutator zaps that power into specific wire coils, turning them into electromagnets that push and pull against other magnets, forcing the whole thing to rotate. And 5, the entire time, that little fan is spinning along with it, keeping the whole system cool. It's just a perfect, seamless chain reaction.
You know, it really makes you think about this quote. We started with a parts catalog that looked incredibly complicated, just a wall of text. But what we found was just a collection of parts, and each one had a really simple, really specific job to do. And when you put them together in just the right way, something amazing happens.
Because when you strip everything else away, when you get down to the absolute core of it all, the entire secret to pretty much every electric motor is this simple, powerful equation. You take electricity, you use it to create magnetism, and that magnetism creates motion. That's it. That's the whole trick.
So let's go back to where we started. Let's look at our Rosetta Stone one last time. It's not just a bunch of weird words anymore, is it? Commutator, diode, varnish. Now you see the story behind those words. You see the system. You see the blueprint for that machine that's been hiding in plain sight all around us.
And that's really the big takeaway here, isn't it? We just took this totally cryptic document and used it to unlock a complex machine we see and use every day. So my question to you is, what's your next black box? What other complicated things are out there all around you, just waiting for you to find their parts list and figure out how they really work?